Trento is the home of the PI of the mission, and so there are a good number of scientists here, and so we do the mission here, include as many of the scientists as possible. I'm Martin Hewitson. I'm a scientist at the Albert Einstein Institute in Hanover.
I'm Bill Weber. I'm from Los Angeles, California, and I've been in Trento for the last 15 years.
So my name's Ivor Thorpe. I'm from the Goddard Space Flight Center, which is one of the NASA science centers in the United States.
I am Giuliana Rossano. I am a third-year PhD student here at the University of Trento.
Mauro Weller. I'm working at the Department of Physics, University of Trento.
My name is Paul McNamara. I'm the LISA Pathfinder project scientist at the European Space Agency.
I am Stefano Vitale. I'm a professor of physics at the University of Trento in northern Italy, almost close to the Dolomites. I'm a physicist, and I've been involved in gravitational wave research all my life through.
My name is Carsten Dansmann. I'm director at the Max Planck Institute for Gravitational Physics and director of the Institute for Gravitational Physics of the Leibniz Universität Hannover, and I'm a professor in Hanover.
Things we've worked on for the last 20 years are now becoming real. It's sitting on a bench, we can see it, and we get to operate this thing. And so the excitement level is rising, and we are just delighted.
We can pretty much count the days till the satellite will be shipped to the launch site.
This will open up a completely new way of looking at the universe for us, so a new field of astronomy.
So I feel excited, yes. We have an end-to-end simulator of the mission. We have already simulated a week of mission operation, sitting there, taking shift. One goes home, the other one stays there, and so on. And it's a pretty well-organized thing. And then we have meeting to understand how the thing went.
We're here in Trento today as part of a development workshop or a development meeting for the data analysis tools and environment.
I can say that the meeting is very productive. We are trying to close many pending actions.
We're looking at the toolbox we use to analyze data. So by the end of this week, we want to have a better understanding of where we are and what we have to do between now and the launch date.
So all of the tools and procedures that we need to be ready in advance of that, well tested, well documented, and ready to go. It's a particularly strange mission, this, or an unusual mission.
When the mission is over, after a few months, we already have the data.
So we have to do a very quick turnaround of data analysis.
Because it's an experiment where we can command the spacecraft to do different things, to make different measurements.
We must analyze the experiments we run each day in more or less real time.
Gravitational waves are something very beautiful. They were brought to us by Einstein almost 100 years ago. They are ripples in the structure of space and time that propagate almost undisturbed through the whole universe. And they are created by masses that are accelerated in an asymmetric way. Gravitational waves are very special messengers. We know that the universe is mostly dark. Almost everything in the universe is not detectable by electromagnetic radiation of any kind, light, X-rays, gamma rays, whatever, because it doesn't emit electromagnetic waves. Anything that we know of interacts via gravity, even if it does not emit electromagnetic radiation. That gives us the hope that gravitational waves are the ideal messengers about anything in the universe, in particular the dark side of the universe.